Hello everyone, welcome back to the channel. Today we are talking about why Israel keeps modernizing its fighter jets without replacing their engines, even in 2026, when technology is moving faster than ever. This idea sounds strange at first, because many people think the engine is the heart of any fighter jet, and if you upgrade everything else, why not change the engine too? But Israel follows a very smart and practical strategy that focuses on results, cost, speed, and real battlefield needs, not just shiny new parts. To understand this, we first need to understand how expensive and complex a jet engine really is. A modern fighter jet engine is not just a metal machine, it is a highly advanced system with thousands of parts, special materials, and years of testing behind it. Designing a new engine or changing an old one is not like changing a car engine. It can take 10 to 15 years of testing, trials, failures, and redesigns. Even a small change in engine design can affect the entire aircraft structure, balance, cooling system, fuel system, and flight software. So when Israel already has engines that are reliable, powerful, and proven in combat, replacing them is not always the smartest move. Israel mostly uses American-made engines in its fighter jets, like those in the F-15, F-16, and F-35. These engines are already among the best in the world, with strong performance, long life, and excellent support systems. Instead of replacing these engines, Israel focuses on upgrading what really changes the outcome of a mission. That means electronics, radar, sensors, weapons, software, data links, and electronic warfare systems. In modern air combat, winning is not just about speed or raw power, it is about who sees first, who understands first, and who shoots first. This is why Israel puts most of its money into brains instead of muscles. By keeping the same engine, Israel avoids massive redesign costs. Changing an engine usually means changing the air intake, exhaust shape, internal structure, cooling systems, and even the flight control software. All of this would require new testing, new certifications, and long grounding periods. For a country like Israel, which must always be ready for sudden conflict, grounding jets for years is not an option. They need jets in the air, not in factories. So instead of tearing everything apart, they upgrade step by step. They add better radars that can see farther and clearer. They add sensors that can detect enemies without being seen. They add electronic warfare systems that can confuse or blind enemy radars. They add smarter computers that connect all this data and show it clearly to the pilot. With these upgrades, an old jet with a familiar engine can fight like a brand new aircraft. Another big reason is reliability. An engine that has flown thousands of hours and survived real combat is trusted. Pilots and engineers know its behavior, its limits, and its maintenance needs. When you introduce a new engine, no matter how advanced it looks on paper, it will always have unknown problems at first. Early versions of new engines often suffer from overheating, vibration, software bugs, or material failures. Israel cannot afford surprises in the middle of a real mission. So they prefer engines that are already proven, even if they are not the newest design. Cost is another huge factor. Developing or buying a new engine is extremely expensive. The engine alone can cost millions of dollars per aircraft. Then you add training, spare parts, new tools, new manuals, and new maintenance systems. By keeping the same engine, Israel saves a massive amount of money. That money can be used to buy more weapons, better sensors, more drones, or better training. In war, having more capable systems overall is better than having a slightly faster engine. Also, Israel does not work alone. It works closely with the United States and other partners. Many of its jets are based on American designs, but Israel modifies them heavily. These modifications are mainly in electronics, weapons integration, and mission systems. Changing the engine could create political, legal, and technical problems with partners. So by keeping the engine and changing the rest, Israel keeps cooperation smooth and fast. Another important point is mission type. Israel does not usually need to fly extremely long distances like some big countries. Most of its missions are relatively short range, but very intense. So fuel efficiency and extreme range are not always the top priority. What matters more is precision, speed of decision, and survival in heavily defended airspace. Engine upgrades might give a little more range or speed, but sensor and software upgrades give a much bigger advantage in real combat. Modern warfare is also about networks. Jets today are not fighting alone. They are part of a system that includes drones, satellites, ground radars, ships, and command centers. Israel focuses heavily on making its jets smarter inside this network. They upgrade data links so jets can share information in real time. They upgrade computers so pilots can see the whole battlefield on their screens. These upgrades do not require a new engine, but they completely change how powerful the jet becomes. Think of it like a smartphone. You can keep the same battery, but if you upgrade the processor, camera, and software, the phone feels brand new. The same idea applies to fighter jets. The engine is like the battery. As long as it works well, you don't need to change it just to make the system better. Israel also believes in fast innovation. They prefer many small upgrades over time, instead of one giant change after many years. If they waited to change engines, they might delay everything else. But by keeping the engine, they can quickly add new radars, new weapons, or new software as soon as it is ready. This makes their air force flexible and always modern. Another reason is logistics. Maintenance crews already know how to fix the current engines. They already have spare parts, tools, and training. If they change engines, all of that must change too. That means more mistakes, more delays, and more accidents in the early years. By keeping the same engine, maintenance stays simple and fast. And in war, fast repairs can be more important than fancy upgrades. There is also the issue of space inside the jet. Engines are designed to fit perfectly into the aircraft body. Changing them might require cutting and reshaping the internal structure. That could weaken the aircraft or change its flight behavior. Israel prefers to avoid such risky changes. Instead, they use the available space to add better electronics and systems. Sometimes they even remove old heavy equipment and replace it with lighter modern versions without touching the engine. This can actually improve performance slightly because the jet becomes lighter. So even without a new engine, the jet can feel more powerful. In 2026, software is more important than ever. A jet today is basically a flying computer. Israel is famous for its software and electronics industry. So it makes sense that they focus on what they are best at. They build advanced mission computers, smart displays, and powerful data systems. They also build special systems to counter enemy radars and missiles. All of this can be added without changing the engine. This is where Israel gets a unique advantage. Another reason is secrecy. When you build a new engine, many people and companies get involved. This makes it harder to keep secrets. But when Israel upgrades internal systems, much of that work can be done quietly. This helps them surprise enemies in real combat. Many times, enemy forces do not know what Israeli jets are truly capable of until it is too late. Engines are also limited by physics. Modern engines are already near the limits of what is practical. You can make them a bit stronger or more efficient, but the improvement is usually small compared to the cost. On the other hand, electronics and software can improve very fast. Every few years, computers become much more powerful. So upgrading electronics gives a bigger return on investment. Israel chooses the upgrades that give the biggest advantage for the lowest cost. Training is another factor. Pilots are trained for specific aircraft behavior. Changing an engine can change how the jet accelerates, climbs, and handles. That means pilots need new training, and training costs time and money. By keeping the same engine, pilots can focus on learning new systems instead of relearning basic flying behavior. This makes the transition to upgraded jets much easier. Israel also believes in battle-tested solutions. They prefer systems that have already been used in real missions. Engines that have survived years of operations are trusted. So instead of gambling on something new, they improve what already works. This mindset has helped Israel survive in a very difficult security environment. There is also the issue of supply chains. Engines need special materials and parts. If these parts come from many countries, political problems can delay supplies. By sticking with existing engines, Israel already knows how to get parts quickly. This reduces the risk of jets being grounded because of missing parts. In 2026, threats are also changing. Missiles are getting smarter. Radars are getting more powerful. Drones are everywhere. To survive, jets need better sensors and defenses, not just more speed. So Israel upgrades systems that help avoid detection, confuse missiles, and strike accurately. These are system upgrades, not engine upgrades. Sometimes Israel does make small changes to engines. They may improve cooling, software, or small parts. But they do not replace the whole engine unless it is really necessary. This balanced approach keeps performance high without risking stability. Israel also watches how other countries fail. Many big programs in the world have suffered huge delays because of engine problems. Some jets were ready in every way except the engine, and that delayed everything. Israel wants to avoid this trap. So they build their upgrades around what they already know works. Another key idea is independence. Israel wants to control as much of its technology as possible. Engines are usually made by very big foreign companies. But electronics and software can be made at home. So by focusing on these areas, Israel becomes more independent. This is very important for a country that may face arms restrictions in the future. In real combat, speed of decision matters more than speed of flight. If your jet sees the enemy first and fires first, you win. That is why Israel puts so much effort into sensors and data fusion. They make sure the pilot sees a clear picture of the battlefield. This is far more valuable than a few extra kilometers per hour of speed. Also, engines produce heat and noise. Too much power can make a jet easier to detect. So sometimes, not changing the engine actually helps stealth and survival. Israel prefers balance over extreme performance. They want jets that are smart, flexible, and reliable. In 2026, modernization is not about replacing everything. It is about upgrading what matters most. Israel understands this very well. They modernize their jets like they upgrade their phones or computers. They keep what still works and change what gives the biggest improvement. This saves time, money, and risk. It also keeps their air force always ready. So when you hear that Israel upgrades jets without changing engines, it is not because they cannot change them. It is because they choose not to. They choose the smart path, not the flashy one. They focus on winning wars, not winning headlines. The jets may look old from the outside, but inside they are among the smartest in the world. This is why, even in 2026, Israel keeps modernizing its fighter jets without replacing their engines.